These are the solutions for the review for the final test, questions 128 through 137. So let's take a look at our first problem here, and we're subtracting rational expressions. So when I subtract, I want to come up with, or add, I want to come up with a common denominator. Now x plus 2 and x minus 2 look the same, but they're not, and so we need to multiply by the other's denominator. So on this one, on the right side, I'm multiplying by x plus 2 over x plus 2. The left side, x minus 2 over x minus 2. Now with the subtraction, there's an extra step I would do. I would add the opposite, and so change that subtraction to addition, next number to its opposite, and then I use the distributive property. So I'm multiplying this 3 over that subtraction, so I've got 3x minus 6. Over here I do negative 2x over that addition, so I get negative 2x squared, and then a minus 4x. And then down below I have the same denominators, x minus 2 times by x plus 2. And I'm going to leave it like that in the factored form. And I'm just going to collect like terms now. So I'm going to take that negative 2x squared, write that first, and then combine all those x's. So I got negative 4x positive 3x makes a negative x, and then this negative 6. And I'm going to rewrite the x minus 2 and the x plus 2. Now if this does factor, the top of the fraction, the numerator, if it does factor and have x minus 2 or x plus 2 as one of the factors, then I would write those down, but it doesn't. So this would end up not factoring to have the factors of x minus 2, x plus 2. So I'm going to leave it just like this. And take a look at the next one, same sort of thing, multiply by the other's denominator, x plus 1 and x plus 1. Over here, x minus 1 and an x minus 1. So I'm using the distributive property again. And so I've got 6x minus 6. And then over on this right side, distribute the 2, I've got a positive 2x and a positive 2. Down below, I've got the x minus 1 multiplied by the x plus 1. So I go ahead and collect some like terms. So when I do that, I combine all the x's first. And so I've got 8x. And then over here I've got negative 6 and positive 2, which make a negative 4. Now there is a common factor between those two terms, but it doesn't leave me with an x plus 1 or x minus 1, so no need to factor it. We'll just leave it like that. Here the denominators are the same already, so I'll just go ahead and collect like terms. When I do that, I add up the 5x squared and the 4x squared, and then combine with that 9x if I can, but in that case I can't. So I'm just going to leave it as 9x to the second plus 9x over 3. Well, here there is a common factor that will reduce the 3. So you see, you could take out a 9x, and so I'm going to go ahead and do that. Take out that 9x, I've got an x plus 1 left over. So x plus 1. So I go ahead and do the division, reduce that fraction a bit, and I've got the 3 going into the 9 3 times, so my final answer is 3x times by the x plus 1. That would be my answer. Same thing over here, collect like terms, but before you do that, add the opposite. So switch both those signs, then collect. And so when you collect that, you got negative 5x squared minus a 10 all over 5. Well, we could take out a negative 5 from each of those terms. And so when I do that, pull out that negative 5, I've got an x squared minus 2. And so down below I still have that 5. So now you can take out those 5s, those common factors of 5 here. So I've got that negative sign and then the x squared minus 2, and that would be my answer right there. Looking at our next one, no common factors here, so we've got another one just like the ones prior to this where we have to multiply by the other's denominator. And so I'm going to multiply the right side by x plus 3 and the left side by x minus 3. And so when I do that, the difference between this problem and the others is I've got to use FOIL for the left-hand side here. So the first terms make an x squared, outside make a negative x, and then I get a negative 3x for the inside and a positive 3 for the last terms. Over here, distribute, and I get a positive x squared and then a positive 3x. And then taking a look at the denominator, I have those same numbers. So I've got the x plus 3 and the x minus 3. And so now I just want to collect some like terms. And so when I do that, I see the x squareds combined make 2x squared. The x's, I got negative x, negative 3x, and a positive 3x. So that makes negative 4x plus 3x makes a 1x, and it's negative. And then it just looks like I have that positive 3. And so that doesn't factor at all, so no need to worry about that. And I go ahead and just rewrite the denominators. And that would be my answer, 2x squared minus x plus the 3. Looking at our next one, it's a mixture problem. So when we've got the mixture problems, what we want to do is we want to set up a little chart. And so the chart goes the amount of solution multiplied by a rate, and the rate is typically, in this case, it's a percentage. Sometimes it's a dollars per pound or dollars per kilogram, but not in that case. And it's the amount of whatever the percentage is of. So it's an amount of salt in this case. And so we go ahead, we got these two parts, part 1, part 2, and remember that we're going to have a low percentage and a high percentage, and then we'll come up with a mixture. So it says a 15% salt solution is to be mixed with a 35. So 15% to be mixed with a 35, so those are two parts, to obtain or to produce. So these are key words here that tell us that now we're dealing with the mix. So whenever you see to make, to produce, to obtain, those are parts that go with the mix. So 35 liters of a 19% solution. And what are they asking for? They want to know how many liters of each are needed. So we're going to call one of these x. So let's call the top one x here. 15% is x. And now this is going to be an expression. Now this is a total. Whenever you're given a total, you're going to set up a problem this way. The total minus the unknown. And then we go ahead and multiply. So when I go ahead and do this multiplication, I get 15x. Here I got to use the distributive property. So I end up with 1225 when I multiply 35 times 35 minus 35x. And these are going to get added together to make the total. Well, I got to multiply the 35 by 19, and I get 665. So now I can set up my equation, and it goes this way. I've got 15x plus the 1225 minus the 35x equals 665. So when I go ahead and do some opposite operations and combining of like terms, here's what I get. I combine the 15x and that negative 35x, I get negative 20x equals, and this makes a 560, and it's going to be negative. And so when I do that division, I end up with x equals 28. So 28 liters, and if you go back into the chart right here, it tells us x is the 15%, so 28 liters of the 15%. And then I do that subtraction, put the 28 right here, and do this subtraction right here, and I end up with 7 liters of the 35%. And it makes sense. So go back always and think about it. Does it make sense? 19 is closer to 15, so that meant I needed a lot more of the 15%. Just a little bit of the 35% is going to bring it up a little bit. So that does make sense. Taking a look at our next problem, we've got another mixture problem, so we'll set it up. An amount of solution, and it's going to be multiplied by a rate, and then we're going to go ahead and equal an amount of salt again. And so we'll go ahead and fill in our chart. Remember, you got part 1, part 2, and then we have the mix. And so we go ahead and start 10 liters. This time they're giving us a part. 10 liters of a 6% solution is to be mixed with a 12% solution. To make, so let's see where they say that. To make, right here, to make a 10%. So that means we're dealing with the mix. This means mix. And now they're asking how many liters of the 12% do we need? Well, we don't know. Now this is different because here we're not given the total. So we have to add those two numbers together, 10 plus x. And then we just multiply. So we go ahead and multiply these numbers and we end up with 60. Here we have 12x, and again, those are getting added together. Here use the distributive property, and so we have 100 plus, and then we have 10x. And so we can go ahead and set it up the same way we had done before. 60 plus 12x equals 100, and then plus 10x. So subtract that 10x from all sides, subtract the 60, and we end up with 40 equals 2x. Divide, you end up with x is 20. So 20 liters of the 12%. And hopefully it makes sense because we have more of that than the 10 liters of the 6%, and 12 is closer to 10, so it does make sense. Next problem, another mixture problem. Again, we'll start off with our chart, amount of solution. We're multiplying by another percentage of salt. And when we go ahead and multiply that percentage of salt by the amount of solution, we get an amount of salt. And again, we have the same thing, part 1, part 2, and the mix. So let's go ahead and fill in our chart. We got 50 gallons of seawater that is 6% salt. So 50 gallons of seawater that's 6% salt. How much fresh water with no salt? So how much, no salt means 0%, should be mixed with the water to get a 4% solution. So it's kind of like the last one where we don't have the totals. So we're going to just have 50 plus x. And so we go ahead and multiply across here. And so when we multiply, 5 times 6 makes 300. Or 5 times 6 makes 30 and add the 0. Here we have 0, so no need to add any numbers there. And then here you distribute, and you have 200 plus 4x. So we set up our problem. 300 equals 200 plus 4x. Subtract that 200 from both sides. End up with 100 equals 4x. Divide, you end up with x is 25. So 25, and this was gallons this time, of the fresh water in order to make that 4% solution. Now it talks about a car leaves town traveling at 56 miles an hour. So now we're into a different type of problem. Distance equals rate times by time. Another car leaves town traveling, and it says 1 hour later, and it's traveling north on the same road at 84 miles an hour. So let's write this down. We got car 1, car 2, and car 1 is going 56, car 2 is going 84. Now it says how far from the town will the second car overtake the first? Well, when they talk about overtake, that means we have equal distance. Equal distance. And so what we're going to end up doing is calling both of them, since we don't know the distance that they travel, both of them let's call D. And now let's go ahead and write in our times. We don't know the time for car 1, so we'll write T, but the car 2 left an hour later. So later means we're not going to have that extra hour, so we've got to take away 1 hour from the time the slower car, the first car, was traveling. And so now we can go ahead and substitute 56t in for that D right there. So we got 56t equals 84t minus 84. So we go ahead and do a subtraction problem here. Subtract that 84t from both sides. And so when you do that subtraction, make sure you put the bigger number on top, and we end up with a negative 28t equals negative 84. So when you do that division, the time at which you end up with is 3. But that's not what they want. Remember, they want how far. How far means distance. So now we got to substitute. Put that 3 back in for t here. So the distance equals 56 times by 3, which ends up giving us 168 miles is our answer there. Well, last problem. And this one talks about a plane leaves an airport, flies due south at 192 miles an hour. So let's write that one in there, 192. And 4 hours later, a jet leaves the same airport and flies at 960 miles an hour. When will the jet overtake the plane? So another one where D is the same. Now, this time they want to know the jet's time. So let's put the time for the jet here because they want to know jet's time. When will the jet overtake? So we're going to put the T there. Now, the plane was flying for 4 hours more than the jet, so I'm going to put a T plus 4. And then I'm going to go ahead and substitute 960 in for this D right here. So 960t equals 192t plus, and this ends up giving me 768 when I multiply the 192 by 4. So I go ahead and do that subtraction, and I end up with a 768 as well. And so 768t equals 768. And so when I do the division, I only get 1 hour. And so that would be our answer. Well, those are the problems you'll end up seeing on that study guide. Check out other parts for other problems.